So where does this function have a tangent line slope of -4? So here's just an imaginary possibility for the function. A slope of -4 for a tangent line would look something like this. Steep going down. That's not quite tangent though. That one looks to have a slope of -1. For the graph I made, I don't know if we ever have a slope of -4 because it's only negative on this interval. Okay, but the big idea is that you're looking for for where the tangent slope is -4. So to find that, you can take the derivative and set the derivative equal to -4, because the derivative talks about slopes, talks about those tangent lines. So if I take a derivative with respect to x, I get 9x squared plus 12x, and the derivative of 19 is 0. And then we want the derivative to equal -4. So to solve that equation, it's quadratic, so I'll set it equal to 0 by adding 4 to both sides. And this is the longer method of factoring, or you could use the quadratic formula. But I try to factor whenever I can. And so factoring when a is not 1, we multiply the first and the last numbers. That makes 36. And then you got to find two numbers that multiply to be 36 but add it to be 12. I think it's 8 and 4. And so you replace that middle term, the plus 12x, with plus 8x and plus 4x. And then you factor by grouping to finish out. So I can put a group around this, and I can put a group around this. And if I do that, oh, it's not going to work out though. What is that? Is that right? 8 times 4. Oh, that makes 32. Sorry, I got the wrong pair. I just saw that factoring by grouping wouldn't work. 8 times 4 makes 32, not 36. What pair do I need? Oh, I need 9 and 3. Those are two numbers that multiply to be 36, but add up to be 12. So I had the wrong pair there. Okay, that should work out now. Because if you factor by grouping, this first group, you can take out a 9 and an x. I don't think that's going to work either. Oh my gosh. 9 times 3 makes 27. I'm not a very good math teacher. I don't know. 36 divided by 4. No, 36 divided by 3. 36 divided by 5, 6. It's 6 and 6. Man, usually I get those the first try. I didn't get it right the second or the first time. Okay, so the magic pair is 6x and 6x, because those are two numbers that multiply to be 36. Those are two numbers that add up to be 12. All right, and now if we factor by grouping, this first group you can take out a 3 and an x, so you get 3x plus 2. In this second group, you can take only a 2 out of both of those terms. Okay, and now since you have two parentheses that are the same, factor out the 3x plus 2, and you're left with 3x plus 2 in here. Maybe quadratic formula is easier for this one. If a is 1, I might even just go with quadratic formula next time. Because now if you want to solve this, it's the same thing multiplied by itself. So this has the same solution repeated twice. 3x plus 2 squared. Right, and to solve that, I would use a square root of both sides. Yeah, so square root both sides, positive, negative, 0, though you can just drop the positive negative sign. And if you keep solving, you get x is negative 2/3. So that's where this graph has a slope of -4. Okay. If you were to solve that and you got something imaginary, then that means there's no solution. Then that means there's no places where the line has a tangent of -4. Okay, since I messed that last one up, let's see if I can get this one right the first time. Take a derivative with respect to x, so the 3 comes down and multiplies. And then we want it to have a tangent slope of 2. So we'll plug 2 into the derivative because the derivative is talking about those tangent slopes. Subtract that 2 from both sides. And I need to finish solving that equation, then I'm done. I'm going to use the quadratic formula this time. Negative b, so negative -4, plus or minus the square root of b squared, so -4 squared is 16, minus 4 times a times c all over 2 times a. Okay, so 4 times 2 is 8. 8 times 2 is 16. So 16 minus 16 makes 0. So this one, if I simplify, I get, oh, that's a negative 4, so that's a positive 4. So I get 1 for a tangent slope of 2. When x equals 1, we have a slope of 2. And you could check that. If you plug 1 into this derivative, 2 times 1 squared is 2. 2 minus 4 is negative 2. Negative 2 plus 4 is 2. So that checks out. So that's the only solution for this one.